Welcome back to question 2 of this series where we calculate the vapor pressure of a two-component solution. We ended off with question number 2, which reads, a solution of benzene and toluene is 25.0% benzene by mass. The vapor pressures of pure benzene and pure toluene at 25 degrees Celsius are 94.2 torr and 28.4 torr respectively. Calculate, we'll start with A, the vapor pressure of each of the solution components in the mixture. So unlike in question number 1, we've been given here the percent by mass. So 25% of the solution is benzene, and that can be represented as 25.0 grams of benzene per 100 grams of solution. Do you know what this means? This means that 75 grams is toluene, and only 25 grams is benzene. This is important because we need the grams and the molar masses of these two, which we will find next, to get the number of moles. So we know that 25.0 grams of benzene is available, and now we'll find its molar mass. Benzene is C6H12, so we have 12.01, that's the molar mass of carbon, times 6 plus 6 atoms of 1.01 grams per mole of hydrogen. Using our calculator, 6 times 12.01 plus 6 times 1.01. That right there is the molar mass, 78.12. 78.12 grams per mole. I'll flip this ratio where I have moles at the top and grams at the bottom, and I'll indicate that with these arrows. So I have 1 mole per 78.12 grams of benzene. Multiply that to 25.0 grams of it. Watch this. These units cancel out, and now we have the moles of benzene. Using our calculator, 25.0 divided by the answer we found, and we get 0.32. We have to do the same thing now for toluene. Shouldn't be hard. Rather than the 6, we have a 7, and rather than this 6, an 8. Again, 12.01 times 7, and it's probably a good idea to show all your work, although I want to save time, I want to save you time, and we're going to add 1.01 times 8. This gives us a molar mass of 92.15, and I'll divide 75, because 100 minus 25 is 75, by this number. Sort of the same thing we did here. Remember over here we took 25 divided by 78.12. In our case for toluene it's 75 divided by the number on your screen, giving you a mole of 0.8138. We just found the moles of these two components, and using these we can actually find the mole fraction of one of them and then obtain the mole fraction of the other. Remember, the mole fraction, let's say of benzene, is the amount of moles of benzene, 0.320, divided by the sum of the moles of the solution, 0.320 plus 0.8138. Again, using our calculator, 0.320, that's the numerator, divided by, again, 0.320 plus the number that we found earlier. It's already stored in my calculator. This gives us a mole fraction of benzene alone as 0.2822. I've shown that number here, and notice that it is unitless because the units would cancel out. To find the mole fraction of the other component, toluene, it's actually quite simple. You can redo what we just did, but if you recall, we can just take 1 minus this number, and we actually get the mole fraction of C7H8. That's the molecular formula for toluene. So 1 minus that number, and it's 0.7177. 0.7177. Now we can use Raoult's law to find the partial pressures of each. So the partial pressure of benzene, C6H6, is 0.2822 times the pressure of 94.2 torr. 94.2 torr. Our final answer should be in torr. And the partial pressure of the other component, C7H8 is 0.7177 times its pressure of 28.4. 28.4 torr. A big difference. So let's go ahead and find out these numbers. Starting at the bottom, I'll multiply what's on my screen by 28.4. That gives me 20.38. 20.38 torr at 25 degrees. And over here, 0.2822 times 94.2, and we get 26.58. 26.58 torr. Remember, this has to be 3 significant figures long, and I haven't forgotten about that. That right there represents the answers for A and B into 3 significant figures. This should be 26.6 torr, and this should be 20.4 torr. Remember, A asked for the vapor pressures of each of the solution components. To get the total pressure, as we did in question number 1, we add these two numbers together. So the number on your screen plus 20.34 rounded to 3 significant figures is 46.9. Those were the answers to A. Question C asks the composition of the vapor in mass percent. This is something new to us. We haven't done this in question 1. But what you do for part C to find the composition of vapor pressure is you take the individual pressures. So we take 26.6, let's say for the benzene, torr, and we multiply it to its molar mass. Its molar mass was found above as 78.12. 78.12 grams per mole. Let's go ahead and calculate this. 26.6 times 78.12, and we get 2077.992 torr times grams per mole. We do the same thing for toluene. It's not shown here, but the molar mass of toluene is 92.14, and that's in grams per mole. We'll multiply that to its pressure of 20.38, and we end up with 1877.81. Okay, so once we find these numbers, we can find the composition of the vapor in mass percent by taking, let's start with 2077.99 divided by the same number plus this number, multiplied by 100%, and this should give us the percent by mass. So 2077.99 divided by 2077.99 plus 1877.81 times 100 gives us 52.53%. And to find the other one, you can redo this whole process, but it's probably just easier to subtract 100 from this. Minus 52.5 gives us 47.5% of toluene. Now you're probably wondering, why is the composition of the vapor different from the composition of the solution? 25 grams to 75 grams. The reason for this is because the vapor is richer in the more volatile component, which in our case is toluene. And there you have it. That is how to calculate the vapor pressure of a 2-component solution.